Hello, Year 8. Now this is your revision video on heat or thermal energy transfer. What you need to be able to, can I zoom in here? So if you look in your booklet, page 31, you'll see that this part of the topic is introduced there. You need to be able to describe the three kinds of heat transfer and the direction that heat energy travels in. So the first one we'll look at is heat transfer by conduction. So make sure that you use the words heat transfer and thermal energy interchangeably. So when we're talking about energy, when we're talking about heat, we are talking about thermal energy. You could see either one of those pop up in your test. The first one is conduction. Now, when we talked in class, we talked about conduction and how some materials conduct more effectively than others. And that's based on the arrangements of the particles in those conductors. Conduction depends on the vibrations, so kinetic energy and the movement of those particles in the substance or in the material will transfer that energy, that thermal energy, to the other particles. And that's how conduction works. This particle will start to move around and transfer the energy to this particle, remembering that that movement, a tiny amount of movement is a lower amount of energy, thermal energy, and the more movement you get, the higher the kinetic energy within those particles, and the more heat energy will be transferred from one particle to the next. So, when you're asked about conduction, you need to consider how densely packed the particles are in that substance. Good conductors tend to have very tightly packed particles that can easily pass the energy from one to another. Good insulators, which are poor conductors, have lots of space between the particles and they find it more difficult to pass the energy from one to the other. So gases, for example, are excellent insulators of heat energy or thermal energy, which is why we fill our double glazing with gas, why bubble wrap traps heat energy very effectively, because it traps little plastic pockets of air all the way around whatever we're trying to insulate. And that air is a really poor conductor of thermal energy and an excellent insulator. Wood tends to be a very poor conductor, more space between the particles despite it being a solid, whereas metals generally are good conductors of heat energy, which is why the teaspoon sitting in your cup of tea will get hot very quickly, whereas a chopstick, a wooden chopstick, you won't actually sense the heat coming to your fingertips, even if it's sitting in a hot bowl of noodles. Okay, let's have a little look at, see, so this PowerPoint is in your files as well. This is just a diagram showing you the teaspoon getting hot and the energy being applied by a Bunsen burner flame to the particles and how that energy is spreading through the metal there. So have a look through that slide or PowerPoint show to help you understand conduction if you're having difficulties, and obviously come and see me or send me a message. Let's have a look at convection. Hopefully that's the next one in your booklet. So the idea of convection, fundamentally you need to remember that as we add more energy to particles, so as we turn something from a solid to a liquid or liquid to a gas, we're adding energy and we're changing the state. And as you change the state, you increase the space between those particles. Now, the more space between the particles, the less dense that substance is, whether that's air or a liquid, and it will actually rise, and that's the basis for convection. So the less dense the particles, it will rise up, and the more dense the particles, it will slow down. And when we talk about convections, often we talk about currents, so cycling around like this. Okay, movement of particles through currents, either air currents or water currents. If you have a look in the slideshow, I think we've got, okay, this is a good example. So here we've got a heater, and the heater's obviously warming the air all the way around the heater. Now what's happening to that air is that as you add energy, the particles are becoming more spaced apart, and that air with the heat energy is rising. As it moves away from the heater, the heat energy is lost to other particles surrounding it, and those particles drop back down, being cooler, and then come closer to the heater again and continue to then move up. Okay, so we have this cycling. The same idea happens in a pan as you're boiling water. The same idea happens in the oceans. Okay, so in the oceans we get warmer water lifting up to the top and cooler water sinking down to the bottom. So convection is the movement of thermal energy through currents. We tend to talk about it in water and in liquids. And the last one that you need to know about is radiation. So notice that when we talk about conduction and convection, we're talking about particles. The movement, the transfer of thermal energy from one particle to the next in conduction, and the movement of particles based on their density and the amount of heat energy in convection. Now, radiation is the type of thermal energy transfer that does not rely on particles, which is why we can get heat energy from the sun in the absence of particles. So through the relative vacuum of space, the radiation can reach Earth from the sun. Radiation is something that we can't see, and it can be emitted from all sorts of things that have high level thermal energy. What you need to know is it doesn't rely on particles, and different substances will absorb or reflect radiation. Okay, so we're talking about harmless. Sometimes you will think about radiation in terms of radioactivity and harm. So we might talk about UV radiation and how that could induce changes in your skin. But here we're just talking about radiation in terms of heat energy. So it's harmless infrared radiation that we're talking about. This can be reflected. So things that are shiny, silver aluminium foil, for example, will reflect radiation and prevent it penetrating through to an object. Whereas you'll notice if you wear a black t-shirt on a really warm day, you tend to get really hot because different colours, a matte black t-shirt will absorb radiation. So the properties of that substance and how reflective it is will determine how much radiation it will absorb. So the key things to remember about radiation is that different materials absorb or reflect radiation to a different extent, and that it doesn't rely on particles. Radiation is the only kind of heat transfer that can travel through a vacuum. I think that is all you need to remember. Well done.